the lecture, welcome. You don't have to, you don't need to ask permission to record this one. Doesn't matter because it is for the sake of knowledge. Um, the other one is make sure that notes are with you. Otherwise, if I talk something, you don't have note with you, so you are basically uh, not focusing and you are lost. And finally, inshallah, the presented note is meaning that the slide will be provided if I feel that happy to provide to you, because at the moment that you are not happy with my notes, so that is why I will keep thinking of giving notes in the future. Okay, before we go to this one, I would like to share a couple of things. This one, uh, I would like to close this one and open up another window. If you don't get the window, you inform me. Otherwise, I don't know whether you are getting the window notes. Yeah, I will assuming that you are getting this one. What do you have in your screen, class?
Okay.
Okay, thank you. So this is the timetable. I know that we are basically on tutorial, but I would like to take the opportunity of the tutorial class to be our lecture. The other thing is, the most important thing is about this one, the schedule. I provide you a schedule. We will try to follow the schedule as close as possible. Even though the schedule will not provide you the test date, yeah, you know that you have two tests. Later on, the school will be notify, will be will be inform you will be the when will be the test take place. You have two tests. Okay, we try to basically follow the schedule here. And I'm sorry, I need to go back to the first one, the first material that posted earlier. This one. Okay. Okay, this is the topic. Don't look for the topic yet. I'm going to look for the assessment. This is why you are here, to be assessed. We are doing the OBE. OBE is basically talking about, if your OBE is talking about the outcome-based education. So anything or everything that you learn in class, even though we are basically in the virtual class, will be tested or be evaluated. Yeah. So one, for example, can you see my cursor here, class? Can you see my cursor now? Okay. So you have two
Yes,
tests.
yes,
The date will
master.
be notified later. You have two tests. The date will be notified later. It will carry you 20 mark per test. That will bring you 40. So at the moment now, the lecture will be based on online 100%. The assessment on test will be notified to you later. I have no idea at all whether it will be in online or will be face to face. I have no idea at all. So it is beyond of my capacity to inform you. At the moment now, stay as is online. As what you have last semester. Project here, project based here. Last semester, we skipped the project because we are in the middle of running the class, and suddenly the class stopped due to due to the situation now. So that is why we stopped the project. What bring the project mark to the assignment mark. So this semester, we feel that we need to give you project only 5%, carry 5%, and you are doing now individually. Hopefully, the project will be will be based on what you have learned. It is not based on you haven't not learned yet. Yeah, hopefully the project title will be ready before the semester break, inshallah. It only carry 5 mark. It is basically programming based to cater the 4.0 IR 4.0. And of course, last but not least, there'll be tutorial or assignment. This is topic based. I will be, inshallah, providing you all the material for the tutorial. Typically, on of course on in groups. Yeah. So later on, we are going to decide whether we want to do this one individually or in groups. That is why we need a class rep to be presenting to you that everyone is agreed to do individually, for examples. And last but not least is talking about final exam. So this one will be 50%. And the mode of exam, I have no idea at all, because there's no formal letter or formal information from the school. Later on, just let's stick the exam will be online. And you add up together, so that will give you 100%. I forgot to give you the idea of what will be the percentage in my class last semester. I think if I can recapture, yeah, last semester my class, I got 4 section. Out of 4 section, only 4 student fails. A plus about 40% A plus. This is not due to the lecture. This is the student commitment in the class. Inshallah, the next meeting I will show you. I will post to you the performance in my class for last semester. This one for UTM space. So I think that's about it for the introduction. So let us move to the topic. So these are the topic we're going to learn. Start with the gear system. We have a couple of special application there: hoist, vehicle dynamic, and epicyclic gear. Then you have an effect of gyroscopic couples due to rotor and shaft, aeroplane, naval ship, and land vehicles. Then you have dynamic balancing. So dynamic balancing will be comprising of rotating on mass, balancing of rotating mass, typically rotor, shaft, and rotor. On the other hand, you have the balancing of reciprocating mass, which is dealing with engine. In here, we're going to look for inline engine, that is very conventional one, and then you move to the V engine and as well as the radial engine. There are 3 types of engine we're going to look for, inshallah. And last but not least, for the topic number 4, we're going to move or look at the fluctuation speed and energy. In some book, if you look at book, for example, written by Kumi, it is not stated as fluctuation speed energy, it is stated as flywheel. Okay, it different name but same content. So we have TMD, that one. TMD is stand for turning moment diagram due to the internal combustion engine as well as the motor drive machine. And last but not least, which is the topic the more challenging, which is mechanical variation. We are going to look for two type of degree of freedom. One will be single degree of freedom, the other one will be 2 degree of freedom. And of course, we're going to look for free undamp, for free damp, and then force damp. And typically for 2 degree of freedom, we're going to look for free undamp, force undamp. And the most interesting part will be the vibration absorber, which is due to tune mass damper. We are going to suppress the vibration on machine, put something device on the machine so that the machine will not vibrate, but instead the device, what you call as tune mass damper, will be vibrating severely, collecting every vibration energy on the engine, and it will absorb itself. We call it the tune mass damper. Okay, that is the topic. So I'm going to close this window. I'm open up another window. I'm open up another window, so you will have with you now notes video, this one. I think you have this one, right? uh, Sorry, I think I better share with you the PowerPoint window, because the PowerPoint window more interesting as there is animation. Do you have this one? Do you have the slide here? Do you have
No,
the
not
gear
yet.
system, animation system? No. Okay, let me share you another time. Where are we? Yeah. Okay, let me share. Where are you? Okay, this one. What do you have in your screen, class?
Yes, system.
Yes,
Do you have
yes,
animation?
yes,
Okay.
Yes, yes.
Shukramdullah. Thank you. Yeah. So now we're going
yes.
to learn about this one. Yeah, we're going to learn about the gear system. Okay. In principle, why we study gear system is basically because uh, um, um, I will share why we study gear. Yeah, why we study gear. Otherwise you keep asking why we study gear, why do we study another form of power transmission. So I will share with you another slide which I can write on it, which I can write on it. Otherwise that one very difficult for me to write. So I will keep sharing a screen, so inform me if you don't receive any screen, screen. This one you receive, right? This one is the static screen.
Yes,
No,
sir.
no animation, isn't it? No animation. This one is PDF. Okay,
Yes, sir.
we are studying gear system. Seem that basically the power, basically what you have is a bit. I'm changing another one. I have a problem of this one, the pull down menu, always disturbing me when I want to change the templates. This one working template. I got a working template here. So please be patient with me. Yeah. Okay. We are basically the you know the big topic is a power transmission. You have this one.
Yes, sir.
Okay. The power transmission is basically, we are talking about power, so it will transmit power. Obviously, transmit power. But you know well that power is given by T dot omega. And if you expand the equation, you are basically talking about torque. And you know well then torque is talking about F multiplied by the radius, isn't it? And this one will be basically talking about kinetics. Can you please off your mic? Otherwise, I have to put this one. Yeah. That one is talking about kinetic on, and you're talking about the velocity here. So this velocity, this is the angular velocity. Is talking about kinematics. Kinematic. Yeah. So the power transmission is not only to transmit power. It's basically transmitting torque. Yeah, torque and angular velocity, and you expand the word, it basically talking about kinetic and also kinematics, what you learn in dynamics. So that is what is the power transmission. So the medium for power transmission, the power transmission, you don't have to talk with this one. This one just to share with you the introduction of power introduction. So the introduction of power transmission. So the medium of power transmission is starting with gear. You have this one rope, for example. You have this one chain and sprocket. You have another one, so many. I think couple of names here you can list it. Yeah. Number 4 could be belting. 5 will be shaft. And the recent one is fission. And on and on. The list will be on and on. Yeah. Even hydros and so forth. But the most important thing is we study gear because researchers say that it is not Muhammad Abdullah mentioned about this one. Yeah. The researchers say that the efficiency reaches about 90 to 95%. So that is why we study gear. But of course, the weakness of the gear, you have what? You have you need to put lubrication, isn't it? You have to have lubrication. Even though now we are talking about smart material, we are talking smart material. This smart material do not need lubrication, but it need air, yeah. Air to be lubricate to ensure that there is no friction and to ensure that the material that meet together will stand as it is, not without failings. Yeah, that is why we study about gear. Okay. The other thing is when you look for gear, you are looking about connection. If you're talking about shaft, you're talking about belting, yeah. So these two pulley will be not connected. Not connected. The pulley connected by using belting. So but gear, yeah, it will connect it physically. It will connect it physically by teeth, number of teeth. Okay. So that is why we study gear. Okay, this one. When I need animation, I go back to the other slide. Okay. Is it okay with you when I keep changing the screen? Is it okay with you, class?
Okay, doctor.
Okay,
No problem.
Okay, because in class I don't need to change the screen, but here I need to change the screen when I use animation. When I do animation, I cannot run on it. I have to use PDF. This is all PDF. Yeah, this is what you have. Okay, the other one that we're going to look for here is definition of gear. For example, as I mentioned earlier, then you have gear train. What is the difference between gear train, gear motions, and so forth. So now let's start with number 1, gear. What is gear? What is gear? Gear is basically what is a wheel, isn't it? With teeth, yeah, with teeth, and the teeth will be having what you call it, pitch. Pitch is having pitch, yeah, pitch here, yeah. Pitch. What is pitch? Pitch is basically a ch, yeah. Pitch is basically this one. This is also pitch. This is sine curve or cosine curve, class. Huh?
Sine curve.
Cycle.
So look at pitch. If you measure one cycle from one peak to another peak, it's one cycle, isn't it? Peak to peak. If you measure from valley to valley, it's also a cycle. If you measure one point to another point, also one cycle. The same as pitch. Pitch will be measured from one tooth to another tooth. Whether the tooth will be at center, at the middle, doesn't matter. So isn't it? What does matter, it must be equal. So that's a pitch. So when we're talking about gear, gear is a wheel with teeth, where the teeth will be the same pitch. Okay, that is one. The other one is the gear train. When you have a gear itself, it is not gear train. Gear train is simply mean that you have a couple of gear, then the couple of gear will meet together. Okay, so for example, you have one gear, this one gear, yeah. For example, I'm not good in drawing. One, this is not gear train, but as you have one gear and support by shaft, you attach another gear, then you call it train. So gear train is what is simply tell you about when more gear connected to each other. So we call gear train. So we have four type of gear train: simple, compound, reverted, epicyclic. We are going to look this one after another later on. This is only to introduction what the topics. Yeah. Then gear motion. Gear motion simply say that when two gear meet together, you must have the internal and external connection. What will be the internal and external connection will be discussed later on. Okay. Then as I mentioned, pitch. And the most important thing is talking about the gear ratio. This is the most important thing about talking gear ratio. And this is more challenging. Yeah? And finally, we start this one by calculation. Then we have gear system efficiency, torque, and this is the spatial application will be on hoist, vehicle, dynamic, and also epicyclic gear. So this is end of topic for gear system. Okay. So this is the introduction to gear. Gear from miniature to a giant size. For example, this one. This is a human size. This is a human radius. This is also human size of the gear. So this was very, very small in laboratory, for example, on chef, for example. Okay, type of gear. Yeah, this is type of gear. This is type of gear. For example, you're talking about herringbone gear, helical gear, inside gear, so on and so forth. Worm gear, for example, and more gear here. And the most popular gear is spur gear. This is the most popular gear, spur gear. And bevel gear also part of a very popular gear where it convert the motion from this one, yeah, the motion of this one be the motion of horizontal to vertical. I'm sorry, vertical to horizontal. That's the change of motion from due to gear arrangement. Okay, gear train. Gear train, we are going to look for four type of gear train. This one. So in exam, yeah, you have two type of equation in exam. One will be what we call as description, meaning that you have to define something. You need to know what be the function of something. You need to know to elaborate the comparison between one to one. For example, what the difference between spur gear and what difference between spur gear and helical gear. For example, yeah. The other one what we call is you have three type. The other one will be you have this one is the analysis. This one all due to calculation, and this one is carry more mark. This one supposed to be, if the whole thing will carry 10 mark, this one is only 2 marks. Then this one will carry about 6 mark, yeah, more marks. Sometimes give 1 mark here. Depends on how descriptive will be the equation. And number 3 here, what we call as CTPA. CTPA is when you have the results, you calculate the result, then you need to know what is the result to be used for. So this is the CTPA, which what we call as critical thinking problem solving. For example, you calculating the gear, you found what be the torque on gear, then you have to check whether the torque, the torque on the gear will allow the bearing fail or not fail, for example. We're going to do this one later on. Uh, so this is the fourth type of gear is basically on the description one. So you need to know a couple of things on description one. Okay, I clear this one. Okay, now so one will be simple. You don't have to memorize the whole term, or the whole sentences. What you need to understand is what is basically simple gear. Simple gear is this is a simple gear. This is a simple gear. This one simple gear. This one simple gear. Yeah. You have this one. Don't bother to copy. Okay. The simple gear is basically one shaft carry one wheel or one gear. One shaft carry one wheel. One shaft carry one wheel. One shaft carry another wheel, and it will be connected to each other. It will be connected to each other. 1 minute, yeah. 1 minute class. Oh, the system. One minute. Okay. Yeah. So here, simple train, meaning that you have one shaft carry one wheel, one shaft carry, and it connected to each other. Okay. So so you don't have to basically memorize word by word to defining or to describing what be the simple gear train. For the compound gear train here, you look at the compounded train. So it is it is describing or it is defined that one shaft carry more than one wheel. So more than one wheel. This one shaft carry two wheel here and connected to another one, connected to another one. So this is what we call compound. This is compound. One shaft carry one wheel connected to another one, and this is a compound. Okay. And if you can move on here to the next page, okay, what we have in the next page, the internet problems. Do you have now this next page, class?
Compound gear train.
Yes.
Okay.
Yes.
This is another one, 4 gear, 8 gears connected to another. This is 6 gear connected to another, so we are called compound gear trains. And the riveted gear train is one. See the riveted gear. So the riveted gear is defined as look at the input shaft and look at the output shaft. So when you found that the shaft of the input and the shaft of the output yeah, in one axis or in one line or in one plane will be called as riveted gear. Okay, here supposing here input and output in one plane, so this one is output, this one input, it is also riveted gear. On top here, this one is input, the other one be output, also riveted gear. So sometime in the exam or in the test here, it will not mentioning about riveted gear, but the drawing specifically talking or dealing with riveted gear. So you need to know what is the definition for the riveted gear. In it The beauty thing of the riveted gear is we will define this equation. I'm going to share the equation later on, not today. Yeah, after we completed the whole definition, then we're going to look what with the equation used for the riveted gear, for example. Okay, this one simple epicyclic gear. Epicyclic gear. So we have 4 just now, isn't it? One will be simple. We finish the simple one. Where are you? This up. Sorry, quite fast. Yeah, sorry. This one, yeah. Simple train, compound gear train, derivative gear train, epicyclic gear train, the last one. So epicyclic gear, you have to understand only four component. When it mentioned about these 4 component, it will basically reflect to the epicyclic gear. One, they must be annulus. Some call outer ring gear. This one sun, some call it's not in a ring, a central gear. The other one is planet or planetary. the use or the function of a planet is basically connecting the sun here and the outer wing gear. This one, yeah. And finally, this planet will be whole or held by an arm. An arm. So arm will be connected to planet. Otherwise, the planet will be, will be moving, randomly. So this one will hold by arm. So this is the arm. The green component is arm. This is what we call an arm. So as any problem mentioning about this component, four component, it will refer to the epicyclic gear. Okay. Any question before we move to motion? Any question?
No, no.
Okay, I will move to another one. Uh, because this one I need motion, so I move to another one. This one. What do you have in your screen? You have the PowerPoint, isn't it?
The animation.
Okay.
Yes, sir.
Gear motion. So for gear motion, if I can still annotate here, but it's not very helpful compared to the other side. Yeah. Because okay. See, will not. It's not rotating because I use annotate. So we can't use annotate. Yeah. When I use annotate is capability of the system to give you or to write something. But when I write something here, so there's no motion. So I better close this one. Okay, this is the gear system. So the gear system, what you have to understand, you have two, this one, internal and also external. External meshing, internal meshing. What is meshing? As I mentioned earlier, meshing to gear, when gear meet together, because first gear, yeah, then gear train. So gear train mean that two gear meet together. The gear will meet together when you have a good mesh. When a good mesh, M-E-S-H, it is not M-A-T-C-H. A good mesh is you fighting each other. This is mesh. Good meshing is basically the T will be inserted well. In some points say that it will be will be no knocking. I will share with you what be the mesh. So to have a good mesh, the pitch must be equal. To have the good mesh, the pitch must be equal. Otherwise, the two gear will not be inserted well. So as the two gear not inserted well, the transmission will not so good. So now external meshing and internal meshing. So for the external meshing, you have the opposite direction, and for the internal meshing, we have same direction. So we look at into this one. What is the opposite and what will be the same direction? Look at here. So this one is all external meshing. External meshing, one will be a wheel, the other one will be the straight gear, isn't it? So external meshing. Look at the external meshing. This is the external meshing here. So the external meshing is when two gear meet together. So the gear will be rotating different direction. This one rotating counterclockwise from your seat. This one rotating clockwise from your seats. Okay. This one first, yeah. Okay, this one look at here. The internal connection. Okay, the internal connection. If the internal connection is simply say that this is the internal connection. Can you see this one? This one is rotating clockwise. Internal, yeah. This one is rotating clockwise. The inner gear also rotating clockwise. So this is the internal connection. Both gear running same direction. Look at the chain and sprocket here. So the chain rotating counterclockwise from your seat. This also rotating counterclockwise from your seat. This one also same direction. Okay. So but if you look at the external connection, look at the external connection. This is the external connection. One be rotating counterclockwise, the other one rotating clockwise. So that is the difference between external connection and internal connection, and it is very important when you look into episode later on. Any question up to here? No.
No, no.
Okay. This one is just to share with you. look at the beauty definition we have to here. Look at here. So you have one gear, you have look at two gear first, two gear, one gear, two gear. When you have two gear, both gear are running, both are gear running different direction, right? Number two is even odd number, even or odd number two, even or odd,
Even.
even. So even number, opposite direction. Look at this one, odd number, three gear. Three is odd number. Gear number one, gear number two, gear number three. You found that the first gear and the third gear running same direction, correct? Clockwise,
Yes.
clockwise. So when you have odd number, you will have a same direction. The first gear and the third gear running same direction. What about 100? 100 gear
Even.
even number.
Right.
So what do we have? Gear number one and gear 100 running same or different direction?
Different.
Different direction. Okay. Look at this one, 4 gear. This one even number, right? Will be different direction. Driver and follower. Okay. That's about it basically. So of course in the exam, yeah, I'm not going to give you this one. This one is so complex, very difficult for me to draw here. What will be given later on will be as such. This is the gear they're going to look for. For example, gear number one, gear number two, 3, 4, and 3, 5, and dash. So on and so forth. This one is one of the exam question, couple of semester backs. Okay, this one, another one. And this is the use of the gear that is studied today is to basically to use in irrigation to lift up the door, yeah, for irrigation purposes, typically a dam. Okay, so we are going to look for gear ratio now. This is more challenging, gear ratio. Look at what you have your gear ratio here. Okay, I'm going to go to another. I'm going to stop sharing here. Then I'm going to give you another screen. This one. This is PowerPoint. Sorry, PDF screen. Yeah. So we up because I need to write something here. So that's why I change the screen. So this one is not motion. So it's not animation here. Okay, look at here. So this is the gear ratio. So the gear ratio is basically the ratio between or the ratio between follower and driver or driver and follower. The ratio of what? The ratio of speeds, the ratio of velocity. Speed and velocity is two different things. Yeah, speed will be a scalar and velocity will be a vector. Then it could be radius, it could be diameter, and can also be number of teeth. So that is the ratio. So we are going to learn about the gear ratio or velocity ratio, which is noted as n. Okay, let me go to template here. So I'm going to clear the whole thing. So let me share you another template. Yep. Sorry, wrong template. Yeah. Okay. This template allow me to write something, like I do on whiteboards. In here they provide you whiteboard, but very difficult to use the whiteboard because when you keep writing and the thing that you write is not well presented. So here, look at here. So the gear ratio is basically is the NO. N will be the speed, yeah, NO divided by NI, or it can be also be written by omega O by omega I. Another person also defined it. Gear ratio be Ni divided by No equal to omega I divided by omega O. So it depends on who define what will the gear ratio look like. So some researchers say that, some books say that. So it is, the ratio between output and input, talking about speed and velocity. On the other hand, some researchers say that it is between the input and the output. So it depends. I did not mention here because when you read other book, you find that these two things will be different. Yeah, some will be O by I, some be I by O. So in here we decide to look at this one because most of the researcher or scholar use this one, but some of them using this one. So we are not going to use this one. But not to forget that some of the book will be written as what here. So we are not going to use this one. It is not. It is correct, but not going to use. Not to be exposed. Yeah. So we're going to use this one. We expose this one. Okay. So I don't want you, when you go back and you find book, you find that, oh, why that this gear ratio is I by O. We study in class O by I. So you have to understand that who write the book and who basically do research on that particular gear ratio. So okay, throughout the course, we are going to use N equal to NO divided by NI for the general equation. Okay, so that is very important. Yeah. So look at number one. Number one now, you have stuff about it. Come on. The pull down menu stick there, so it will close my here. Okay, look at here. Do you have what do you have in the screen, class?
Middle school and secondary.
Okay, you don't have to write this one. You have this one in your notes. Okay, this is driver. This one is the driver. Yeah, driver is sometimes you call driver, sometimes call input. Driver, this one is driven or follower, same thing. Sometimes call output, can be output, can be input. Yeah. So you have this one, two this meet together. So in dynamic, you study dynamic. There is one topic in the rigid body motion. You found that topic called that no slipping. This last topic in dynamics. In here that it does mention about these two discs meet together, and these two discs representing by a gear, you pick up one point here and you project the point, you will have the velocity here, and the velocity is a common velocity. The common velocity will be named as v1 equal to v2, the common velocity. And if you open up the bracket, so it will give you omega 1 r1 equal to omega 2 r2, isn't it? But you know well that the gear ratio, as what we defined earlier, is omega O by omega I equal to omega 2 by omega 1. So equal to R1 by R2. Am I correct? Isn't it? So you found that you have now another term. It is not O by I, but instead you have 2 by 1 and 1 by 2. Okay, and it can also be prolonged, that it becoming two radius is becoming diameter. This one will be d1 by d2. Okay, and as this gear, or as this as you are talking about non-slipping this, so you are basically talking about gear. So as this one be keep changing velocity, what happen when velocity change? What happen? What do you have when the velocity keep changes? What do you have, class? You have
Different.
acceleration, yes. Don't write, yeah. Don't write in chat session. Just answer, yeah. You write. I basically cannot pick up what you write on the screen. So you have the acceleration. But remember this one. The acceleration now is basically the acceleration on the tangential, isn't it? Again, this spot point, what you call nodal point, the nodal point here will give you the common acceleration. And if you can expand the equation, it becoming 1I tangent, sorry, a1 tangent equal to a2 tangent, and you expand the equation, become alpha 1 r1, this one is alpha 2 r2. And again, if you put up the equation now, it becoming here alpha 2 by alpha 1. Oh, sorry. This one becoming what? Becoming alpha 1 by alpha 2. Correct? Isn't it? Okay, this is now about if I can rearrange the equation. Yeah, you have okay omega O by omega I. You have omega 2 by omega 1. You have alpha. Uh, 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 oh, sorry, this one is supposed to be. I'm sorry. Yeah, this one is supposed to be. It is correct just now. It is correct just now. It's alpha 2 by alpha 1. This one is alpha 2 by alpha 1. Alpha 2 by alpha 1 equal to R1 by R2 equal to D1 by D2. It is not up to that. We are going to look in another one. Look at here. Let me share it with you. Pitch. Remember pitch? This is the pitch as I mentioned earlier. It's exactly representing like the sine wave or cosine wave. The pitch is measured from one end to another end, from one end of thoughts to another end of things. So this one is pitch. So if you are talking about center, for example, yeah, you are measuring from center of the thoughts another center of things. So this one, as this one go along, you find that they becoming circumference, which will give you number of pitch multiplied by pitch multiplied by number of things. Am I correct? So you go back to the equation what we have earlier. So you found that for good meshing, P1 must equal to P2. And you found that the C just now, C just equal to 2 pi R, fine, is equal to PT, isn't it? And if you equate the equation, it becoming P1 is equal to 2 pi by T11, isn't it? So you have P2 is equal to 2 pi 2 by T2. And if you simplify the equation because P1 equal to P2, you found that it becoming 2 pi R1 by T1 is equal to 2 pi R2 by T2. So it becoming R1 by R2 is equal to T1 by T2, as this one will be cancelled off. Am I correct? And you take this one and you put it in the equation. And finally, your long equation will becoming as N now is equal to NO is basically NO by NI is equal to omega O by omega I is equal to alpha O by alpha I is equal to R1. Oh, sorry. It's no longer here. Sorry, yeah. No longer 1. Supposed to be used 1 and 2 is rather still. So you have omega O earlier just now equal to omega I is equal to omega 2 by omega 1 is equal to alpha 2 by alpha 1 is equal to N2 by N1 is equal to R1 by R2 is equal to T1 by T2 is equal to D1 by D2. This is a very long equation. You don't have to copy this one because you have with you in your notes. You have notes here written, well written as shown here. This one, yeah, this one you have. Okay, class. But remember, yeah, in the exam, it is not be given you by numerical or numbering sequential 1, 2, 3, 4, 5. No, it be sometimes given by A, B, C, D. So it's very difficult for you to memorize the whole thing. So I put it there, a simple term to memorize in two different category. One category is saying about kinematics. The other one category talking about geometrics. And you found that for the kinematic, it's always output, output, output divided by the inputs. And for geometric, you found that all input, input, input divided by input. So it is inverse, isn't it? It's inverse from the geometric and kinematics. It's always kinematic, it's always output by input. Geometry is always input by outputs. Is that clear?
Yes, sir.
Clear, sir.
Okay, yeah. So you don't have to memorize 1 to 1 to know. You just memorize, okay, for kinematic, output input. For geometric, input outputs. Okay. So that is the first equation we study today. Is a general equation for gate ratio. Now we move to simple gate train. Simple gate train the two train we already calculated just now. I'm not going to do this one. Okay, this one is as what we do earlier just now. What when you have 4 gear or 3 gear, for example? Let's assume you have 3 gear here. Okay, as you have 3 gear, remember this one. We have 3 gear. gear number 1 attached to gear number 2, gear number 2 attached to gear number 3. As you have 1 and 2, for example, you're focusing on 1 and 2, and you cut this one. You ignore gear number 3, only 2 gears now, isn't it? So the connection between 1 and 2 can be represented by N12. So N12, again, you will have this one, omega O by omega I. This one input, this one outputs, correct? Or this one gear number 1, this one gear number 2. You will have this one as such. Then you ignore gear number 1. You focus gear number 2 and gear number 3. You have another connection, this one. So the connection, this one will be gear 2, 3. And again, this one is output, this one now becoming input, because you try to ignore this one because we are doing part by part connection, part by part. So you have another one, gear 2, 3, this one. But for the long range equation from gear number 1, gear number 3, you cannot have this one. You must have what you call as overall gear ratio. Is the multiplication between these two gear ratio, and then you start collecting the omega, for example. As you're collecting the omega, you'll be getting as such. And this is a simple mathematics. Can cancel, will bring you to this one. And again, when you select the number of this, you will have this one as such. Then you cancel this one, cancel this one. You will have this one. Okay, this is now a simple gear train. For example, you have 100 gear now. A range in simple gear train. So what will be your gear ratio? Equal to what? Omega 100 divided by omega 1 is equal to T1 by T100. Isn't it? Don't bother do 1, 2, 3, 4, so on and so forth. Because you know well that for the simple gear train, always take the last gear by the first gear for the velocity. Take the first gear to the last gear by the geometrics. Is that clear? Yes or no?
Yes.
No,
Yeah.
sir.
So remember, this one only for simple
Yes.
train.
Clear.
For simple train. For simple train. Okay. But perhaps you might ask me why we don't use radius and also diameter. The reason is why in gear ratio it is very difficult for us to measure the radius, because the radius is not as what the radius is. This one, because you have this here, they're very difficult to not measure the radius as well as diameter. So that is why we keep on using the velocity or speed and number of it, because number of it is easy to count. Yeah. Okay, we move this one. This is gear number 4, as I mentioned earlier. Gear number 4, take it this one. You don't have to do this one. No, don't have to do this one. Just use this one. But of course, in the exam, for example, the question asks you prove this equation. Then you have to do along the line. Okay, you have 4 gear, you have 3 connection, 1 connection, 2 connection, 3 connection. Okay. Compound gear train. So for compound gear train, as I mentioned earlier just now, compound gear train is basically when more gear connected to each other, isn't it? One shaft carry more than one wheel. 2 wheel, 3 wheel, doesn't matter. So on the other hand, if I can share with you a bit, yeah, before we start doing the calculation, this is another example for compound gear train. Look at here. If I'm not mistaken, I put it here. Hold on a bit. This one, look at here. This is the compound gear train, isn't it? Look at here. So many gear attached to a shaft. So this is a compound gear train. Simple gear train is very rare you found, because simple gear train we need a more compartment, because the arrangement of this shaft is not very neat. Yeah. Okay, you go back to the other one. Okay. We stop at this one. Okay, gear ratio for a compound gear train. Compound gear train. Look at here. For compound gear train, for example, here gear number 1 here, gear number 1, then we gear number 2, gear number 3, and gear number 4. And obviously, this one is input, this one be output. If you consider the whole range of gear, but if you manage to consider only gear number 1 and gear number 2, so the connection here representing gear 1 and 2. This one representing here, yeah. This one, yeah, representing gear what 3 and 4. On the other hand, here representing 5 and 6, isn't it? So if you do one up, you when you open up the bracket for n12, for example, you'll be getting as such. Am I correct? You do for 3 and 4, for example, you have this one as such. Always output, input, output, input. This one input, outputs. Huh? And if you go further for the next one, you will have as such. That one the individual connection of the gear, but the range of the gear from 1 to 4, if you add up together, sorry, if you multiply together the product of 1 2 up to 4, you'll be getting as such, and you start collecting omega, for example. You're collecting omega here, and you found that here, yeah, you found that you cannot cancel the term. You cannot cancel the term, right? Because you found that 1 2 3 and 4 5 and 6, but you forget about one thing. What is that? That is one shaft carry 2 gears. As this shaft carry gear number 2 and gear number 3, you found that omega 2 is equal to omega 3, isn't it? And this shaft carry gear number 4 and gear number 5. Again, you have gear 4 equal to gear 5. So you can cancel this one, 2 and 3, 4 and 5. Finally, you will have as such. Okay, and finally you have 1 2 3 4. You cannot do anything about this one. This one is the arrangement or multiplication of every number of teeth. If you 12, it will be 12 gear. Huh? Okay, so in conclusion, for compound gear train, this one will not change anything, isn't it? It's exactly as a simple train, but this one does change. The simple train is always take the last gear to the last gear to the first gear. This one will be multiplication for every number of teeth. So that is the difference between the two gear train. Okay. Okay, now let me give you another. Okay, yeah. You have just now simple train. You have compound train. You have epicyclic. Oh, sorry, reverted gear. And the other one will be, what will be the last one?
Epicyclic.
Epicyclic. So we done this one for gear ratio. We done this one for the ratio. This one you don't have to do anything, because this one, the reverted gear and also a epicyclic gear, will be a part of compound gear train. So whatever you have n just now can be used for epicyclic gear and also reverted gear. So in conclusion, you always have two equation for gear ratio. One will be simple train, the other one will be compound gear train. Reverted gear and epicyclic gear as the same as compound gear train. Okay. The other thing that for reverted gear, as I mentioned earlier just now, what is the reverted gear? The reverted gear, when you found that the input shaft and the output shaft will be in one line, isn't it? And you found that it is correct. Okay, this is the reverted gear. So you found that you can you can use the equation. You can develop equation. For example, this is another shaft. So the distance of this shaft to another one is 3 by 3 and 4, 4 and 3. The other one is 1 and 2. Is the additional of 1 2 3 4. You will have this one, isn't it? And you found that when these two gear connected, the pitch must be equal. P1 equal to P2, P3 equal to P4. You will have this one, P1 equal to P2, P3 equal to P4. Okay, then you add up together. Finally, you will have this equation. This is the most important equation when you found that you will have reverted gear. For reverted, this is only for reverted, eh? This one we already done earlier. Okay, power. Can I move on, class?
Yes.
Yes,
Okay,
doctor.
what is power? What is power? In dynamic, you find power is equal to F. eh, Power is equal to F dot velocity. That in dynamic, you studied this one in dynamic. This is the rectilinear motion. Velocity, force multiplied by the velocity. But if you do the angular motion, because typically gear involve the angular motion, you have P equal to F dot velocity. The velocity will be in terms of omega arm. So you put in the equation, you have P equal to F dot omega cross arm. So basically you have P equal to this one and this one become torque omega. That's what you have. Okay. Torque and omega is a cross product because why? Because you have force here, multiply this one, it become torque. Omega is here, is cross product. Okay, this is the gear efficiency. The gear efficiency. You have couple of things you have to understand here. One will be saying that if the gear that we are talking or dealing with is it's not it is supporting by bearing, yes, but there is no friction torque on bearing, or we might be saying that this one is frictionless. As you're talking about frictionless here, so it is so definite that the Ti here is equal to T1. We have T1 here. This one is T2 torque. This one is Ti is torque on shaft input. This one T1 is torque on gear number 1. This one torque on gear number 2. This one here To is torque on gear on shaft, yeah, on shaft. So if there's no friction, you find that T1 is equal to Ti, T2 is equal to To. That's why you have this one. Otherwise, this one cannot be. Okay. So you have this one omega To omega O Ti omega I. Then you know that this omega can be can be put in other form. Remember this one? You look at here. It can also be put in the form which is T1 by T2, isn't it? Or can also be written this one. Remember T1 by T2 by N12, isn't it? So you take this one and change this one. It become as such and become as such. Then you start manipulate the equation. Manipulating the equation is basically to look for whether you want to look for To or you want to look for Ti. That is manipulation of the gear. This one, yeah, of the gear. You have this one in the notes. This one don't bother. This one I explained earlier. Torque. This is the most important thing. Talking about torque in gear train. Torque in gear train. Okay, before we start this one, I would like to share you a bit that why okay, here torque in gear train. Doesn't matter whether you are dealing with gear train, come from a simple one or come from compound, doesn't matter. So torque in gear train. When you are doing this one or you want to do something about developing the equation, you need to understand about references. So there are two references. One will be input shaft, the other one will be output shaft. Input shaft and output shaft. Okay, so why it is important? Because you want to know whether you are going to look for input shaft and output shaft. And this one will be depends on input and outputs. Depend on input and output. I will explain to you later, in details. Yeah. So just understand that we have two reference. Look at the input shaft, look at the output shaft. So what is the input shaft and output shaft? Look at here. Then I explain to you how to use the input shaft or the output shaft as reference. So before that, who decide this one? Who decide the reference? Who decide the reference? Who decide? You or the equation? You decide. This one you have to decide whether you want to refer to input or you want to refer to output. If you select different or wrong input, you'll be getting 0 mark or wrong answer. So you must be selecting the correct reference, whether refer to input or refer to output. So how to do that? We're going to look this one. Okay, the input shaft is basically the input reference is basically when you're talking about a system where you have a system as shown here. You have a gear here, then you have a shaft here. Of course, the shaft will be supported by bearing. You have FBI, this one. This FBI representing friction torque on bearing. It is friction torque. It is not friction, yeah? Friction torque on bearing. How do you know friction torque on bearing? You look at the SCAF book, the manual for the bearing manual, SCAF book. Look at what will be the friction torque. The new friction will have a very small friction torque on bearing compared to the old bearings. The old bearing mean that the bearing been used, operating 100,000 of rotation, for example, and attached to gear, another gear. The minute that attach now, you will have N12, isn't it? And you will have the efficiency. You don't attach, you don't have this one. If the gear will be running rotating, by itself and not connected by gear number two, you don't have N12 and efficiency of 12. Then this gear number two is support by shaft and carry by bearing. You have FBO. This FBO is friction torque on bearing output. This one friction torque on bearing input. We assume that only two gear meet together, and this one is to develop the equation comprising the friction. Comprising the friction. Okay, that is when you're talking about input shaft as reference. When you're talking about output as a reference, the same system. So it simply means that you walk or you travel from output shaft and go to the input. So here you meet TO first. Just now you meet TI, isn't it? Now you meet TO first. Then you meet FBO. Then you meet T2. Here the connection will give you N12 and N12 and the efficiency of 12. The other one will be the torque gear number one, and this one will be the friction torque on bearing input, and last but not least will be the TI. So these are the different things, two different reference and two different motion. Okay, understand that? Yes or no?
Yes.
Okay,
Yes,
now
sir.
we are trying to do this one after another. We try to assuming that we are going to take input shaft as a reference now. Yeah, input shaft reference, and we are using the same problem here. Okay, here this is the one. You have this one in books, yeah, notes, yeah. Oh, before that, before I forget about books, yeah, some of you might asking me whether my books will be sell or on shelf or not, for them to get the books. Yeah, very unfortunate I'm saying here, because due to the situation, I'm not going to print the book because it's very difficult for me to post to you, or you want to take the book is very difficult, because the book is always available in the school. So for this semester there will be no book sales. How do you get the information? Will be doing online materials. Okay. um, but if you requested to have that book, I'm not promising this one anything. Yeah, if we come back on January, hopefully the pandemic this one will be lift off. Yeah, so the MCO is lift off, the pandemic also lift off. So on January, if you come back to the faculty, you can request for the printed notes. I will print for you. At the moment, there is no printed note. Okay. Some of you is messaging and email to me to get the printed note. I'm sorry about that. That's not printed note because it's difficult for you to send the book to you. And they are also talking about the ebook. I'm not going to do that one for ebooks. Yeah. So this method you have to work a bit hard, but you can contact your senior and buy from or take from your senior if your senior is close by. Okay, come back to this one. You found that this one is the same system as above, so we are going to look for talk here. So as you refer to input, remember this one, as you refer to input, it simply means that you are going to use input as your reference and your equation will start with inputs. How to do that? Simple, this one, look at here. This is input, correct? Input Ti is equal to T1, this is torque, yeah, plus FB1 plus I alpha 1. Say then you start asking me what is I alpha 1. So I go back to this uh, the template. So what you learn here, shaft. So you have summation of moment, isn't it? Equal to I alpha plus MA. This is what you learn in dynamic rigid body motion, the last topic in your dynamics. Okay, for rotate, this is rotating about fixed point. This is rotating about a fixed point. You found that this A now here become 0, so there is no here. This one, isn't it? Then it become as this one. So you will have a summation of M equal to I alpha. This one basically it's not 0, yeah. If you remember what you learned earlier, that one is basically coming from the equation. This one is not, it's supposed not to 0, yeah. I don't want to prolong this one. This one you're done in dynamic. So but I want you to recall you learned this one as MAD. You open up the bracket, is basically alpha equal to M. This one is alpha R. This one is D. Let's assume this one is R. So R equal to D. So you will have here I alpha plus M alpha R square. Isn't it? You learn this one in your dynamics. And finally, you look at this one is equal to, this one is equal to I alpha plus, this one is M alpha R square. Alpha and alpha can also be, as a common term, and you will have this one. Then finally you have alpha, isn't it? Okay, this one you done this one in dynamic. So just have this one. What is the one? This one is the initial. Is the initial. So go back to this one. The initial one here, you have the initial I alpha. You have another one initial for here is I O alpha initial, yeah, initial. So if the velocity, for example, constant, do you have the initial or not? Anyone? Hello?
Uh,
No,
No
no,
initial.
no,
You still have it,
no.
right?
no.
You still have a moment initial, right? But you don't have the initial. Two different things, yeah. Mass moment initial and initial, two different things. The initial is the capability of the system or body to move on, decelerating or accelerating. But mass moment inertia is as for a body rotating about one fixed point. That is the mass moment inertia. So now you have this one, and this is for the first part for this one gear here. This is input. Again here, if you cut into two pieces, you found this one now become input to the structure, right? So this one input, you have this one input again. Input for gear number 2. So T2 is equal to TO plus the friction plus the initial for the input output shaft. Okay, and these two are now for input from the gear number 1, input for gear number 2. So but this T1 we calculated earlier due to the talk earlier in principle. You have this one T1 equal to, remember when you manipulate the equation just now here, this one you manipulating the equation here, this one. So you take back as this one, you will have as such. If you forget, don't worry, you use as usual as Evan said is equal to T2 omega to T1 omega 1. Do this one if you forget. Same thing, okay, equal to T2 by T1. This one is gear ratio 1 to, then this one is 1 2, isn't it? Because it didn't 1 2, so you want to take T1. So T1 is equal to T2 the gear ratio efficiency. So if you forget, start from the principle, don't worry. Okay, start from the principle. It's very difficult for me to clear the screen. Yeah, you found that it's easy, no, but very difficult. Yeah, that's I did mention that it is so challenging to me. Yeah, because this is my last semester in my career. Yeah? Anyway, as I have this one gear number one, then gear number two here, I put it here. So you be getting a very long equation, isn't it? Look at here, the long equation here. Then you expand the equation. This one is nothing much. This one expand equation. How do you expand? You take this one, Ti, from the above. This T1, you take, we put it here. So you have as such. Now it become a bit longer. Then you expand it, you multiply the input. This one, you get this one, and this one. You open up the bracket. And finally, you know that this one all O, suddenly this one you have I. So you change this one to become some other form, you become this one. How is it? Is here. Remember about this one? And finally, last but not least, you be getting as such. Here. Then you can simplify this one. This one you simplify that one. You will have as such, such, and such. Please do on your own here, class, this one. Okay, this is the equation now. So I simplify the equation to become as such. That is not the problem. That is not our problem because this is due to the derivation. Not problem. Our problem now is how to use the equation. Now our problem is how to use the equation. This is the problem. How to use the equation. Okay. Okay. Now I'm going to share with you a bit how to use the equation. Take this one. What do you have in your screen, class? What do you have on your screen?
But general equation
Okay.
Question.
and complete equation.
Okay. Thank you. So look at it. I'm going to share with you how to use the equation. We already generate the equation. This one, right? We already generate the equation. Now we're going to use the equation. How to use the equation. So we don't have any motive here. Supposingly you want to look for Ti, for example, is obviously that is coming from Pi omega I, that equation. But now To refer to I is equal to, as what we hear earlier, we have To multiplied by gear number 2 divided by efficiency. For this one, correct? It is correct. But what if you have some other gear instead of this one, instead of 2 gears, now you have 4 gears, for example. 4 gears. 2 gears, yes, but when come to 4 gears, you have to modify on your own. We ignore the bearing, yeah, because we are focusing on the O only now. The O, this one is the I, correct? This one is gear number 1, gear number 2, gear number 3, gear number 4. Okay, and I'll change the ink now, or the color. So you have here, of course, when you meet together here, this gear meet together, you have the gear ratio of 1 2, you have the efficiency of 1 2, you have the gear ratio of 3 4, you have the efficiency of 3 4. So applying this one in conjunction with this problem, so you have To refer to I is equal to, you are traveling from input, correct? You want to go to output, yes it is. You have to what? You want to go to output, yes it is. You have to meet gear number 1 and 2, yes, correct. Then you meet another gear ratio 3 and 4, isn't it? This one 3 and 4. Then you divide it by the respective efficiency. Is that clear? Yes or no? Supposingly it is not up to here. This is normal shaft. You have another gear connected here, another gear connected here, another gear. For example, yeah, this one gear number, this one no, this one normal gear. Number 3, gear number 4, gear number 5, gear number 6. This is your TO now. So you tell me what do you have for TO refer to I now? TO, correct? So tell me what is TO refer to I now? Speak up, please. Yes. What do you have? I can hear you.
1, 2, 3, 4.
Multiply by n one
Okay.
two
1, 2, 3,
1,
4.
2,
Then
and 3, 4,
Five,
and
six.
4, 5.
6
five six
divided by
Okay.
respective
efficiency.
frequency.
1, 2, 3, 4, 5,
Where you have
6.
N12 is basically T1 by T2. N34 is basically T3 by T4, so on and so forth. It's not very difficult, isn't it? It's not very difficult. What you have to understand is how to manipulate the equation, to use the equation in terms of solving the problems. So remember this one, this TO referred to I is not equal to TO, yeah? It's not equal to TO. This one is not equal to this one. This one will be TO multiplied the whole range of the ratio. This one is what? This one is TO. TO refer to input. TO this one, you refer to input. That's why you have to multiply every gate ratio. Okay, this TO, if this one attached to drum, for example, yeah, for example, let's see, for example, these two, and the drum will be lifting a mass, for example. So this TO, you have, okay, then you have a free body diagram, you have this one F, this one be mg, this one will be MA, put up, isn't it? Summation of F equal to MA. You will have, okay, anything that pointing up is positive. Then you will have, F minus mg equal to ma. Simplify m equal to mg plus e, correct, in Newton. Your TO now is equal to what? That F multiplied by radius of drum. So that is the TO. Okay, so the TO that we put it here is the TO at the drum, for example, at the bell, for example, at the machine, for example, at the generator, for example. So it is not the TO referred to I. Okay, that is make things clear. Huh? Okay, class, is that clear?
Yes, sir.
Yes, yes.
Now I'm going to put another one. This one is what? Yeah. So yeah, it's very difficult for me to clean up the screen and Discord. This, if you can see this, pull down menu is always disturbing. Yeah, that is the system. I cannot, cannot help out. Let me put the number one again. Okay. Sorry. Sorry, yeah, wrong file. Same file. This is my working template. Um, if you want to see why I don't use the whiteboard, I can share with you why the whiteboard is not helpful to me. I don't know about the other lecturers. You look at now. Okay, number one now you already finish. Number one, this one, yeah. Now, for F be referred to I is equal to, due to this one. This one now you have to look for this one. Okay, FB equal to I. Um, okay, then you move from here, you meet FBI first, isn't it? This one you focus on FBI, don't focus anything. Focus on FBI. You meet FBI, then you go further. This one is not correct. The notation is not correct. The notation is not correct. The notation is supposed to be, this one is FBI plus. Then you have FBO here, But as you go to FBO, you meet one gate ratio. This one is multiplied by N12 divided by 12, isn't it? So whatever now. So this is for that particular system. So what if you have another system? Let's say you have 4 gate as what we have earlier. Gear number 1, gear number 2, gear number 3, gear number 4. As I mentioned again just now, focus on bearing. Let me draw this one red in color. So you have bearing, Put it the bearing A, bearing B, bearing C. You move from here, input. So F be referred to I is equal to what? Could anyone tell me? Just now you meet FBI first, isn't it? So this one become, there's no FBI here. What you have is A, B, and C. So it become become what? Hello, become what? You meet A first, plus then you meet B. But before you meet B, you have to meet gear ratio here. So multiply by the gear ratio 1, 2 divided by 1. Then you go to C, multiply by the gear ratio, you meet again. You have N1, 2, you have another one, 3, N4 divided by 1, 2, 3, and 4. But what if you have another here? Yeah? This one A1, A2. So what will be the equation now become? So this one will have A1 plus A
plus A2.
bracket plus. What have this no bearing? So this one be equal to 0. Okay. What if this one C1 plus C2? So this one becoming C1 plus C.
1 plus C2.
So it is not very difficult. What you need to know is to understand how to use the equation. Okay. Any problem up to here? We have another couple of minutes before we end our session for today. Any problem here? I wish I can use. I can finish the equation only. Okay, no. Okay, fine. So I move to another one. I move to another one. So I pick up another one. Okay, now the last equation. This one is the I equivalent referred to I is equal to steal from input. Yeah, our traveling. So what is the I equivalent referred to I? Is this one? We call this one the whole thing as I inputs. Anything they carry by shaft carrying gear, shaft carrying bearing, we call it I input. This one we call it as I output. So you will have here I inputs plus I outputs multiplied by the gear ratio you meet, that is here, is N12 divided by efficiency. But not to forget you have power of 2 due to derivation earlier. You have power of 2. Most of students fail, to put this or forget to put this power of 2. So the rest, the last equation will be totally wrong. Okay, that is very easy because you have only two shaft. What if you have so many shaft? For example, as what we have earlier. Forget about bearing. Forget about bearing. So this one is 1. This one gear number 1, gear number 2, gear number 3, gear number 4. This one is I. This one, put it here. We name it as I, gear number 2, gear number 3. This one we name it as I O. So how will be the equation look like? So this one be I, correct? Plus I, we multiply
I
by
to
that
3
1 to the power of
and 1, 2.
1 2 and
plus I O. This one is N1 2 N3 for power of 2, power of 2, 3. It's not very difficult, isn't it? It's not very difficult. How sure are you whether it's correct or not? Count how many shaft you have. One shaft, two shaft, three shaft, one equation, one term of equation, two term equation, three term equation. Same thing as the bearing just now. Same thing as the bearing just now. If supposingly, if you go back to the earlier one, and the bearing, put it the bearing now. We have the bearing. Let's see, you have bearing here just now. Bearing E, this one, bearing B, this one, bearing C. So you have the F bearing I is equal to A plus B N1 to MC1 to plus C N1 to 3, 4. 1, 2, 3, 4. Check on the shaft with bearing. Shaft with bearing 1, shaft with bearing 2, shaft with bearing 3. So you have 1 equation, 2 equation, 3 equation. If there's no bearing, for example, only 2 bearing, this one B become 0. Okay. So for FB refer to I and also I equivalent refer to I, always look at shaft. Refer to shaft. Of course, for bearing, look at shaft with bearing. This I only look at for bearing. For shaft. So obviously this alpha I. If you want to change this alpha I, this one to become some other form. We will learn this one later on. How to change this one to become some other form. Okay. So before we end up this one, I would like to make a conclusion. Look at the way our equation. Oops, so yeah. The output I will explain later on. Yeah. Look at this one. Special consideration. So the consideration now, supposingly you dealing with a system in stable condition or steady state condition, you are dealing with speed constant, you are dealing with torque reaches maximum speeds. So this speed term will be basically representing what? No changes in velocity, isn't it? Correct. So as there is no changes in the velocity, your alpha becoming 0.
0.
So as this one, no change in velocity coming, the whole equation, this one, right? Yes. The whole equation, this one becoming
0.
okay. What you have to put here because alpha 0, so this one becomes 0. So put it there. Sin the system running the constant speed, for example. We need that reason to give you mark because that apply that you understand why that the whole thing that equation becomes 0. Okay. How do you look into that? You have to go back to the system if you want to see how the equation look like. Sorry, how the sentence applying or reflecting this is the module I mentioned earlier, reflecting the constant parameter. So you have okay, look at this one. For example, problem number 1. So figure 1, blah 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 blah, calculate the following. Okay, 1, the maximum torque developed by the drum. So the maximum torque, what happens when the torque is maximum? So the velocity is constant, isn't it? So the velocity constant, alpha becoming 0.
0.
Look at the next one. You read the whole thing and then you mention here the adjustable gear A and B can match one at a time and cutting down at steady speed. What does mean? The velocity also constant. So alpha becoming 0, alpha I
0.
becoming 0. So that will be the term that we'll be mentioning in the equation. Yeah. And last but not least will be in steady condition, for example. And then they keep mentioning about constant speed. There are two terms, which is redundancy, because you have two parameters telling you about v constant, so alpha equal to 0. The reason I put it at 2 because some section mentioning about constant speed. In my class, I did mention about three different things. One be the steady condition, maximum torque, and also constant speeds. Inshallah, I'll be providing you this one for the assignment purposes. Okay, so this is the example number 2. You supposed to have so many example if you have the book here. Yeah, for example, if you have the book, you have at least 2 or 3 example in my books. For example, but very unfortunate I can provide the whole thing. So I managed to give you only the example that relate to the course, and you know the example. It basically you can answer or you can do all the tutorial, including test and also exam. Okay. So the next meeting we're going to do this example too. So any problem before we end our first meeting? Yeah. So any comment?
No, Doctor.
Any comment on the lecture?
No. Okay. Very
Who's on the
good.
line? Who's on the line? Can anyone comment on the lecture? You feel bored or whatever, so I can improve the lecture, so that in the next coming lecture, inshallah, you feel no, you feel alive a bit.
No,
Anyone?
very good. Good explanation.
The explanation is what?
Very good. Explanation is very good.
Okay, thank you. Thank you for your concern. So if your friend, for example, want to join the class, let him, give him the link so everyone can join the class. Of course, I will close the door, or I will, lock the lecture 10 minutes or 15 minutes after the lecture. Otherwise, you keep in and out, very difficult for you to, to control the participant. Because I know a couple of you waiting, at the lobby, not sign in external user. No, I'm not going to allow him because it's a bit late now. Okay, if there's no question, first foremost, I will say thank you for your attention. I don't want to be uh, please put your representative class rep in group. Select one of you to be class rep, so I can deal with him or her to ensure that whether the assignment, whatever it is, should be submitted individually or group, or should be submitted printed notes or online. So you need to have a class rep to represent you. Anyone can be a class rep. You can volunteer to be a class rep. No discrimination on gender. Boys and girls can be representative groups. Then we decide how many person in group we want to do in grouping. Then what will be the date to be submit. Otherwise, if there is no class rep, I will decide my own. Okay, next week submit assignment. There is no appeal, no request from group, because there's no leader, there's no class rep. Okay, is it okay with you, class?
Yeah.
Okay, so time come to end. It's 11 now, 15 to 11, 10 to 11. So I wish you all the best. Thank you for being with me. I hope you enjoy my class, enjoy my lecture, and looking forward to see you again in my next coming lecture. So I'll be providing you, inshallah, all the tutorial, but not notes, not because no application from you for the notes. So for the assignment, yes, because you need to do the assignment, because assignment carry marks. So with that, I end my session. Thank you very much, class. So see you again. Stay safe, and assalamualaikum warahmatullahi wabarakatuh.
Thank you.
Thank you so much.
Thank you, Dr.
Thank you, sir. Better.
Okay, thank you.
Waalaikumsalam, sir.
Thank you, Dr.